All right, guys, so here's my finished sketched scatter plot. Notice my scale is a little bit different than the scale on the computer, so that's why it kind of looks a little bit more squished, but again, I can still see that fairly or moderately strong linear pattern. Okay, so let's flip it on over to the second part here. All right, so this at the top says that we are talking about displaying relationships, and we're talking about correlation. So correlation, so we have a relationship between two values, and we will really focus on linear correlation, relationship between two variables, I should say. Okay, so we're first going to talk about being able to interpret R. Now, I'm not going to write all of this out, but R is the correlation coefficient. There's kind of a long reason why it's called all that. Sometimes it's called a little bit longer name, but correlation coefficient is always part of that name, and it's always represented by a lowercase r. And we're going to learn how to calculate this again using StatDisk. We're not going to calculate this by hand, but there are some things that we need to know about it. So one is that, let me go back. I'm going to use that same order, that SDFU. So R will tell us the strength of our correlation, of our linear correlation here. It will also tell us the direction, and I'm actually going to start with the direction because that's the easiest thing to notice. It's either going to be positive or it's going to be negative. Okay, I guess it could be 0, in which case it's not really positive or negative, but usually it's one or the other. So it will tell us the direction. So I'm guessing if we looked at the R value for this scatter plot, it would be positive because this is a positive relationship. So then let's talk about strength. It can be closer to -1. It can be closer to -0.5. It can be closer to 0. It can be closer to +0.5 or closer to +1. So we kind of have some descriptions of those. If it is closest to -1, then it is strong and negative. If it's closest to +1, then it is strong but negative. On the other hand, if it's closer to -0.5, it's moderate but negative. And if it's closer to +0.5, it's moderate but positive. If it's closer to 0, it is weak. Okay? So again, it can be anywhere between -1 and 1. Closer it is to 1 or -1 or an absolute value of 1, the stronger it is. The closer it is to 0, the weaker it is. Okay, so we have strength and direction that it tells us. It also, whenever we're talking about form, for correlation, it's always talking about a linear form. It's not going to tell you how well it fits a quadratic or how well it fits an exponential curve. This is always talking about how well it fits a line, a straight line. Okay, it does not tell us about unusual features. So we have to be really careful to look at the scatter plot to see if there are unusual features, because the next thing we're going to talk about is how R is affected by those unusual features. The last thing, though, I want to mention is that we use those ly words for in-between values. Okay, so say we have, 0.75, that's between 0.5 and 1, that would be moderately strong or fairly strong. Okay, so then the next topic we need to talk about are the properties of correlation. So first of all, R doesn't have units. Doesn't have units, and it's not affected by the units. So say we're talking about, height, and first we put it in inches and then we change it to feet. When we compare, let's say, height to age, regardless of whether we use the inches measurement or the feet measurement for the height, it's not going to change the relationship that height has with age. R would stay the same. Okay, and the same is true if we switch the variables. So switching the axes or saying that you're switching the explanatory and response variable doesn't change R. We're still talking about the relationship between two variables, and so that R value does not change. All right, now this is what I was just talking about with unusual features. R is non-resistant. It means it doesn't resist outliers. So if you have outliers that are in the pattern, but say they have a much larger X value and a much larger Y value than the other values, that outlier is going to strengthen the relationship. And if it's just one value that's contributing to that strength, we really don't want that. On the other hand, if you have outliers that are out of the pattern, they weaken the relationship. So like we pointed to peanut M&Ms earlier, that weakens the relationship. Okay, that's peanut M&Ms because it does not fall in the pattern. Now, to speak to the outliers that are in the pattern, we could look at this value here. Its sugar value is much higher than any of the other sugar values, but its calorie value is also a lot higher than most of the other calorie values. So this is also considered an outlier. It's just in the pattern. It helps define that linear pattern. So this one strengthens and this one weakens. Okay, so then our last thing that we need to say is that correlation does not equal causation. So it's really tempting to say that if I increase the sugar, the calories will go up because we have a knowledge of the relationship between sugar and calories. But that's not true for all variables, right? It's not just seeing the relationship that proves that causation. Oh, no, Oscar. Sorry, guys. My kitten. We're going to look down here at number 3 and see an example of when two variables are related, but it does not make sense at all to say that they cause each other. So be careful. Just because they have a relationship does not mean that they cause each other. Okay, so let's go ahead and talk about how to find R. So in the next video, I'm going to walk you through how to do this on StatDisk, how we press all of these different buttons.